Is that good?
Yeah, perfect.
Perfect.
So it's an honor to have Jonathan here with us today. So Jonathan is a research scientist at NVIDIA, and prior to that, he earned his PhD at McGill University. And at NVIDIA, he works on many things. He's passionate about computer vision, synthetic data generation, and reinforcement learning, and he spent quite some time on leveraging synthetic data for object detection, pose estimation, and few-shot learning. So please, Jonathan, we are curious to know what was your kid's dream.
Thank you, Alberta. Well, it would be hard to match Katrina's energy. Thank you for the great talk. I wish I was giving that talk. It was like all the things I wanted to do, and when I started are like you're like touching on everything. It's really cool. Do I need to put the microphone on this thing? It's just this, okay, cool. All right, so I came up with the title this week. So building bridges. So let's talk a little bit about about me. So I'm from La Belle Province de Quebec, a very cold place. I came from the land of ice and sea. So it's really cold, and I'm from a small town, and this is going somewhere. So this is the town I'm from. It's called Château-Star, the blue star, and then there's nothing around there. There's just like emptiness. It's like nothing north, south, east, west. It's just like anywhere. But we wanted to go to Quebec City because that's the biggest city that's the closest, about 5 hours, 6 hours drive. And then you would think like there's a direct line from the two cities, right? Like kind of following the river. But no, you kind of go around because if you zoom in that little location called Tadoussac, there is a big river. And the big river, in order to cross it, you would need to use a boat. And then my dad is a builder, right? And he's like, I don't like that. This is taking forever, especially in the summer. Like there might be a lot of traffic and there's only one boat and you have to wait like a couple hours so you go around. And my dad was like, I would love to build a bridge, right? I want to build a bridge. And then as I'm growing up, I'm thinking about building bridges and I want to be a builder. But then I ended up doing computer science. I'm not like this like very strong person building like physical things. And then I saw this, I don't know Gendentra, so I'm just going to use whatever he said because it really got me in heart. You agree with Gendentra? Yes. Well, interesting. We'll talk about it. This is kind of like the robotics is far too important to be left to roboticists. So it got me thinking, am I insulted, right? Am I roboticist? Like, am I not good enough for Gendentra? But also I do other things than robotics, right? I do computer vision, right? Like robotics and computer vision. And then they're two different worlds. When I go to a robotics conference, I show really cool videos of my robot doing amazing things and all the great ideas that I have in the physical world. And then I go to a computer vision conference and then I show a table. And then my stats are very good because like my averages are better than your averages. And that's all that matters in the end. All right, there's a big gap between these two cultures, right? And what if I was actually building a bridge between these two places, right? That's my dream, right? So let's look at some statistics, right? So this is me this week, vibe coding. So I downloaded all the abstracts from CVPR from 2015 to 2025. And then I looked at the word counts for robots, robotics, embodied, right? And then as you can see, there's like kind of a trend going up and the y-axis is the percentage, right? I started working at NVIDIA in 2016. See, I think I'm the reason why the robotics has been more and more welcome at CVPR, right? What is it? Oh, Alberta, I think, is saying that correlation doesn't equal causation, right? But does it? I don't know. Maybe. So how did I have that influence over the space of CVPR? But like, I'm kidding. I'm a bridge builder. I want to bridge the gap between NLP and robotics. I want to crossing the bridge between computer vision and robotics, and then laying out the bridge between the agentics and robotics. So these are the kind of three topics I want to talk about. So let's look at kind of LLM. So this is the work prog prom was a 2022, we're very lucky in our timing that we were working on this just before ChatGPT, like a couple months, and it came out like, I think a week or two before ChatGPT, and then it really skyrocketed the experiments of like doing robotics and LLM at the same time. So on this slide, like you have a task, and then on the left-hand side, you're saying like, okay, here's the sort of API to the simulator. Here are the state of the simulator, what is in the world of the simulator. Here's an example of how you're gonna write some code, and here's your task. Like, I want you to cook salmon in the microwave because that's the kind of person you are. Then the LLM is gonna generate the plan. It's gonna do a prompt, and then we'll do some analysis on the code. If it works, it doesn't work, and then eventually you're running it, and then it works. But this is kind of fun, but really I want to have it running on the robot, right? So we use, for state acquisition, we use VILD, which is you put a bunch of words and then it finds segmentations based on the words. And then after that, we can do some motion planning. This doesn't sound very well connected from the perspective of the LLM and the vision or what we're seeing, right? So there's a kind of, they're not as expressive each other. So how can we solve that problem? So this was our work at CVPR this year, RoboSpatial. So in thinking about sort of leveraging VLMs to do some robotics experiments, we're looking at the capabilities of VLMs in the real world, right? You want to be pointing at some objects, you want to figure out some relationships between objects, right? And then what we found out is they're really bad at like anything for reasoning. At least last summer they were. This year is a little different. So we started this, like, we wanted to understand a little bit more about how to train these models and generate data. All right, so there's different things we're interested in: spatial context, capabilities, configuration. We'll talk a little bit about this. But first of all, in using 3D, there's all these reference frames that are important. And it makes a difference, right? So egocentric. So if I'm looking at something that doesn't really have a reference frame, then in front of me, right? So the footstep on the left, like as I'm moving around, the footstep on the left its front is always going to be defined by my point of view. But then the guitar, if I sit in front of the guitar, as the guitar, I'm moving around it, the front doesn't really change. But if the guitar changes, stop playing. If the guitar changes its orientation, then the front of the guitar changes. And then there's a world coordinates, regardless of what happens in the world coordinates always stays the same. I move, objects move, nothing really changes. So with that in mind, can we build a data set with that information? So what we use is we took 3D bounding boxes, we put them in a 2D map here at the bottom left, and then from there we were able to do some reasoning using heuristics to figure out like what is left, right, and front, right. We could move these bounding boxes as well. Is the bin and left of the cabinet? Yes. So this is our spatial configuration question. There's a context, right? So the point, the vacant space in front of the cabinet. So these are pixel coordinates. And capability, can you move something somewhere else and make it work? And I'm very happy to say that our averages are better than their averages. So if you train our model on, this is a CVPR paper, right? If you train our model, if you train a model on our data and you test it on the spatial reasoning data sets like Blink or Spatial Bench, then our model does better than if you didn't train with our data set. But really, the ultimate goal of all of this is to run it on a robot, right? So here it is, working on a robot. But there's still some like little bits here that you need. You need a system to figure out, like go grasping an object, right? So you point on an object, and then the robot, we have a system that figures out where the object is, a grasping point comes down, picks it up, and then puts it into a pick and place system. Well, this is very exciting, but now I have another problem. I can't have, the system is not, it's hard to compare the system to another system, or at least like from a robotics perspective, right? So can we leverage simulation? This is kind of echoing what Katrina has been doing. Can I use a simulation to help us like kind of like benchmark all of these things? And then, for example, if I give you the scene and I say pick the fruits in the bowl and the rest in the container, Like you could go crazy. You could be like, oh yeah, I'm gonna take the image, I'll take SAM, I'll segment everything, I'll take all of the objects, and then I'm gonna send them to another VLM, and that's gonna give me the description. I'm gonna find all of the objects in the scene. Then I'm gonna have this beautiful scene graph, and then I'm gonna take that scene graph with a prompt, and I'll do like a prog prompt type of thing, LLM, robocode, virtual, blah, and then it sends on the robot, then it works, and like you're like, this is so cool, it works, and I'm so happy. Write a paper, send it to a conference, and then, oh, what about a VLA? You didn't compare with a VLA. This doesn't, I'm like, oh, but it works and it's so great. They can do things that I've never seen. But yeah, a VLA. Have you seen the data set size for JCO robot, like a Kinova Gen 3? And then is your argument that a VLA is going to solve these tasks? I don't know. So instead of being very frustrated about my reviews, I was thinking like, okay, maybe I can figure this out in a better way, right? I can sort of understand comparisons in a way that we could like, it would be a little better, right? So if I render here, this is like what we're currently working on. I think that we're presenting this work at another workshop with Jenny is going to be doing it on, I think it's Wednesday. So if I give you a render image from before a task and then a sim API, then we're going to define an interface for you, and then you can use your system, and then after that, send it to the robot. But also at the top part could be a VLA interface, right? So you could have a benchmark for either if you're building a system with computer vision and motion planning, or you could have a VLA kind of, this is very exciting. Now you'll be able to compare any systems to a VLA. And it was going to make my life a lot easier. All right. So some of like what we're looking at is like a full scene state, a little bit what we did for ProgProm, right? No visual perception required. So if you want to do a pure like kind of coding agent, you are going to have also annotated rendering scenes. So some VLM system, they use segmentation on the objects, or like they'll have like a scene with a bunch of like segmentations, and then or letters, and they'll say A, B, A, C, D. I think S3 is kind of my favorite. It's like you just render the scene, there's just depth, and then from there you go, right? And then the 3D point cloud, I think there's really cool work on VLM point clouds, but they're not very well explored in terms of their applications in robotics, which now I'm making a bold statement, but I'd like to see more of the kind of the 3D stuff being applied to robotics in the context. And then what I've kind of discussions I've had with computer vision people are very interesting, because they are not really thinking about the problems of robotics. They feel like it's as accessible as computer vision, right? So in computer vision, I made the joke about the averages and foreshadowing this. When you're doing averages, it's really cool, but if you have like 2 errors over there, it doesn't really change the average all that much. Maybe it even improves it. And then you're very happy. But in robotics, if you're building on a system or anything, and there's like a small error, the error can just like turn your robot to fail at its task, right? And that creates a lot of difficulties in terms of measuring and accepting the reality of doing robotics. And it always shocks the computer vision people when they come into our lab and then we show them robotics experiments, and they're like, oh my God, this is so difficult. Like, why do you need 5 monitors, and why do you need like 13 terminals open, right? So I'm very excited to like think about like to go back to this and about building bridges. All right, so this so I did some research, right? So this is robotics is far too important to be left to roboticists. Actually, it comes from La guerre, c'est une chose trop grave pour la confier à des militaires, which is translated, war is too important to be left to the generals. Georges Clemenceau, it's a very old. So thinking about it, I'm like, this is grounded in the idea that society together, we have to build things, right? And I feel like us roboticists are the generals, right? Like we're right there, we're leading the charge. But what's important is for us to, with everyone else, is to build bridges to improve our relationships with these communities, and also make the work accessible to them. So their improvements on their algorithms improves our robotics, and then the improvements on our robotics systems improves their algorithms on their side. And hopefully we get to experience that. Yeah, I'd like to thank many of my collaborators. This is just a small subset. Yeah, thank you so much. Also, as you're thinking of a question, I feel like feet are underrepresented at CVPR, as you can see here. Body, eye, hand, head, all like have a pretty good percentage of papers, but feet, like really, very low.
Wow, thank you, Jonathan, for the very inspiring talk.
Thank you,
It
Albert.
was very insightful, but also fun. So again, while our next speaker sets up, let's open the floor to 1 or 2 questions from the audience. Does anyone have any question? Okay, maybe I have one. So as you discussed a lot, like building bridges. So how did you do that? Or what do you think is the best way to build in these bridges? Because I agree very much with you that these two communities, if they cooperate, they could lead like to amazing things, but we really speak a different language. So
Yeah.
what's your take on
we see it a lot in the robotics community, trying to do more like the computer vision communities. Like tables are becoming, I've seen it, tables are becoming more and more and more important. Like your averages have to be better than my averages. I think it's one way. You change your way to be more like someone else. So now these people have your respect, right? They look at your papers and it's more, oh, okay, it looks more like my paper. And then it's one way. I think providing interfaces, like an interface to the problem, because the computer vision community, they're very interested in robotics. Like there's a lot of like, I was at CVPR last week. A lot of people are like really into it. But how to get into it is very difficult for them, right? Because a real robot is very hard even to start with. But it would be interesting to have, like, I'm thinking the simulation or the stuff, the simulated kind of benchmark that we're trying to work on towards is a place that we could start building. And then this is so far my way of trying to like bridge that gap, but it's difficult.
Yeah, definitely. Then looking forward to see how that develops. Okay, well, let's thanks once again,
Thank you so
Jonathan.
much, guys.